Hi everyone, we're starting our next section on problem solving with quadratics, and we're looking at section exercise 9D. So what we're going to be doing is we're going to be taking all these different methods of factorization or solving for x with quadratics, and we're going to apply them to real life situations now. So before we do any of that, though, let's just do a quick review of what expectations are in terms of problem solving. So the first thing we're going to do definitely is going to be to name your unknown. So for example, let x equal the width, let y equal the height of the tree, so forth. The next thing you want to do is you want to write down the correct equation. Now, of course, that is going to turn out to be the more difficult of the parts of the things to do. And then after that, what you're going to do is you're going to solve the equation. And solving the equation means that you could be using either sum and product with your quadratic. So you could be using sum and product as opposed to using the quadratic formula, as opposed to completing the square, as opposed to splitting the middle term, removing common factors. All those things that we've looked at so far are going to be in there, okay, possibly. And you're always going to choose the easiest of the methods. And once you've solved the problem, then you're going to see how reasonable the solution may seem in the context of the problem itself. And then you're going to write your final answer in a sentence form, meaning that you will write out for me something along the lines of, therefore the length of the triangle base is equal to, or is blah blah blah, whatever. Okay, so let's get started on the first problem. And the first problem is here. A farmer wants to enclose a rectangular garden with 100 meters of fence. And it says, if the garden is x meters wide, we are to find the length and the area of the garden in terms of x. Okay. So the first thing, of course, is that if we're looking for something or a solution in terms of x, it means that what we are actually finding is we're rewriting the formula in terms of x. So I'm not getting an actual number answer coming out of this part A question, but I'm getting the formula that would bring me to a solution, and everything will be written only with x in it, so numbers with x. So let's take a look at, we have our rectangular garden, and I'm going to call the width, so I'll say let x equal the width of the garden, and therefore, because we have 100 meters of fencing, then I know that this is going to be 100 minus 2x. So that means that I will let 100 minus 2x equal the length of the garden. All right, so if I have to write this out, though, write the area, so I've written out the length. I've written out the length in terms of x. So we've done already part A right there, finding the length in terms of x. Okay. Now, if I were to do the second part of that, where I have to find the area, well, area is really equal to the length times the width. Now, if I know that the width is equal to x and the length is equal to 100 minus 2x, then technically area is equal to x times 100 minus 2x. Oops. 100 minus 2x. And therefore, my area would turn out to be 100x minus 2x squared. Now, 100 minus 2x squared could actually be reduced down if we divide everything by 2, so that it would go to 50x minus x squared. All right, so that would be my second part here, and how we would write the area out. It would be 50x minus x squared. Now, they want us to find the width of the garden with an area of 525 meters squared. So in part B, all we do is we say that 525 is equal to 50x minus x squared, and we'll say that x squared minus 50x plus 525 is equal to 0, so that this will go to two numbers that multiplied give me 525 and added give me negative 50 are going to be x minus 35 and x minus 15. Now, I could have done several things here, but I chose to use sum and product because I knew what the terms, what the factors would be. However, if you don't know that the factors are 35 and 15, there is nothing stopping you from just writing it out as by using either the quadratic formula or even by using completing the square, although I don't really highly recommend that you complete the square because you're just going to get very large numbers here. Okay, but you could use the quadratic with negative b plus or minus b squared minus 4ac all divided by 2a to figure out what your x values are going to be. Alright, so we know that the side then is going to be x minus 35 is equal to 0, or x minus 15 is equal to 0, so that x is either equal to 35 or x is equal to 15. Alright, so if my value of the x, let's see what the question was asking, find the width of the garden. Well, since we said that the width was equal to the value of x, therefore the width of the garden is going to be either 35 meters, I think it was meters, or 15 meters. Okay, I'm not sure if it was meters or units. Yeah, it was meters. All right, let's take a look at the next question. So the next question is basically asking, is it possible to bend a 12 centimeter length of wire to form the legs of a right-angled triangle with area 20 centimeters squared? So the first thing I would do is I would definitely draw out my triangle. And the question is asking, can you bend a 12 centimeter length of wire? So the amount of wire that you have, okay, we know is 12 centimeters. And what it's asking is, can we bend this in such a way, okay, so that it will make a right-angled triangle with an area of 20? So what we want to do is, well, we can certainly call one side of the triangle x. And so we say, let x equal the length of one side of the triangle, and therefore 12 minus x is going to equal the other length, or the other leg, the other length of a side of a triangle. Okay, so if this is x and this is my 90 degrees, then this is going to have to be 12 minus x. Now, since we know that the area of the triangle is 20, using our formula for the area of a triangle, area is going to equal base times height divided by 2. So base times height divided by 2 means that I will take the base x and multiply it by the height, 12 minus x, and I will divide that by 2. And by doing that, I'll get 12x minus x squared divided by 2. And I know that my area is 20. Okay, for the area because it was given. So we have, by bringing everything over to one side of the equation, we're going to get rid of the denominator, so we can say 40 is equal to 12x minus x squared, and bringing everything over to one side, we get x squared minus 12x plus 40 is equal to 0. Okay, now if there are, I don't think there are any two numbers that multiplied together give me 40 and added give me 12, so I'm going to go to the quadratic formula because I don't want to complete the square. Although I could. Let's try the completing the square. That's fine. So we'll complete the square. So in completing the square, I will say x squared minus 12x is equal to negative 40. And then x squared minus 12x, half of 12 is 6, and 6 squared is plus 36, or plus 6 squared. And that equals negative 40 plus 6 squared. This will go to x minus 6, all squared, equals negative 40 plus 36 is negative 4. And if I try to take the square root of both sides, I discover that it's not possible. Because when I take the square root of negative 4, my solution comes out to be the root of negative 4, and that's not possible. I can't take the square root of a negative number. And therefore, your final answer here should be, since I can't get the x-intercepts, or since I can't solve for x in this case, then I'm going to have to say, therefore, that the wire cannot be bent to form the triangle that they're asking for, or to make the sides, or to make the lengths of the sides. Okay, so it cannot work. All right, let's look at the next one. All right, so a rectangle has a length 3 centimeters longer than its width, and its area is 42 centimeters squared. So let's get our rectangle. Our rectangle is here, and it says that it has a length that's 3 centimeters longer than its width. So if its width is x, I think I drew this triangle upside down. Let's see if we can fix it. I think we can. There we go. And ta-da, we got it. Okay, so we'll just bring it further down. All right, so we know that it has a length that's 3 centimeters longer than its width. So we say, let x equal the width, and we'll say that x plus 3 equals the length of the rectangle. So we can say that area is equal to length times width. And since the area is 42, and it's equal to the x times x plus 3, then we can say that 42 equals, and now we're going to expand here, so it goes to x squared plus 3x. Therefore, 0 is equal to 40x squared plus 3x minus 42. So all we have done is, all I've done really is I've just brought everything over to one side of the equation, and therefore I have to find two numbers that multiplied together give me 42, but the sum of those two numbers has to equal 3. Okay, so I can't really think of any numbers that multiplied gives me that product, or summed up gives me 3. Therefore, I'm going to go for the quadratic formula here. So I'm going to use the quadratic, since we used completing the square in the last one, so that I'll say that my value of A is equal to 1, my value of B is equal to 3, and my value of C equals negative 42. So that I'll do negative B plus or minus the square root of B squared minus 4AC all divided by 2A, and that'll tell me what my value of X is, excuse me. So that I will say negative 3 plus or minus, and it'll be 3 squared minus 4 times 1 times negative 42. That's all under the square root sign. And that will all be divided by 2 times 1. So when I solve this, how about if we do this together? Okay, so just solving this, I'm going to do underneath the square root sign. So I will do 3 squared minus 4 times negative 42, enter, and we get 177. Now I'm going to take the square root of that, so I'll do second function, square root, and then I will go to second function answer, and I'll find that it's 13.3. So now I know that under the square root sign, I've got 13.3. So now all I need to do, all I need to do is I need to say that x, so I'm just going to move over here, I'm going to say x is equal to negative 3 plus or minus 13 point, I think we said 13.2, I hope I'm right, 13.3. So 13.3 all divided by 2. So that my two answers coming out here should be either negative 3 plus 13.3 divided by 2 or negative 13 minus 13.3 divided by 2. And so we'll have two solutions here. But let's take a look at both solutions. The two solutions would have, I will have 10.3 divided by 2, and this one would go to negative 16.3 divided by 2. So x equals this and x equals that. Now, negative 16 divided by 2, regardless of whatever the number is going to be, which will be negative 8.1, just in case you were interested, negative 16.3, so it'll be negative 8 point something, okay? Now that, because the answer coming out here is going to be negative, then that means that I'm going to disregard that as a possible answer. So here my answer would be negative 8.15. Now negative 8.15 can't be, because I can't have a negative length. Therefore, I disregard the negative answer as a possible answer. Remember that we look to see how reasonable answers are going to be. Okay, and a negative answer it just can't possibly be. So when I do 10.3 and I divide that by 2, now the other option, I end up with 5.15. So I know now that the value of the width is going to be 5.15. So I can say, therefore, the width is going to be 5.15 centimeters. And the length will be 5.15 plus 3, because we said that the length was 5.15 plus 3. So it would go to 5.15 plus 3, which would take me to 8.15. So that we have the second, we have our length as well. Therefore, length equals 8.15 centimeters, and width is equal to 5.15 centimeters. All right. I just want to go through one more question, which let's take a look at part B on this question. Now here we're looking at proportions, so that I can say, in looking at proportions, that if I were to look at this side and this side, I'm going to look at the small red triangle versus the big triangle, which I'm just going to leave in black. Now if I were to compare the lengths of the sides and so forth, these are going to be in proportion to each other. So what that means is that I can compare, and if I need to figure out what x is, I could make a comparison of the triangles here and say, well, x is to 5 as 4 is going to be, pardon me, not x is to 5, but x is to x plus 5 as 4 is going to be to x plus 3. And what I can do here is cross multiply, and so the cross multiplication would give me x times x plus 3 equals 4 times x plus 5. Now all I did here was I just got a common denominator, and I've already removed the denominator of x plus 3 times x plus 5. So that we get x squared plus 3x is equal to 4x plus 20. Now I would bring everything over to one side because I want to figure out what the value of x is. So it would become x squared plus 3x minus 4x plus minus 20 is equal to 0. so that I would get x squared minus x minus 20 is equal to 0. Here, I could use the quadratic, I could use the quadratic formula, I could use the completing the square, but I choose at this point to use sum and product, because sum and product is easier in this particular question, because two numbers that multiplied give me negative 20 and added give me negative 5 are going to be x minus 5 and x plus 4. That equals 0. Now from here, I would use my null factor law and say that x minus 5 equals 0 and x plus 4 equals 0, so that x would go to 5 or x would go to negative 4. Now, keeping in mind that our value of x cannot be a negative number, I'm going to have to disregard x equaling negative 4 as a possible answer, and therefore my value of x will only equal 5. So when I need to look at what the lengths of the sides are here, I can say therefore x is equal to 5, and therefore the remaining base here, and the base is going to be x plus 3, which is equal to 5 plus 3, which is 8 centimeters. So it's 5 centimeters for the side length of the triangle and 8 centimeters for the base length of the larger triangle. Okay, I'm done. You can look at the homework in section 9D, which you should be completing sections 1 through to 12. All right, see you next time.